Good morning, dear students. In this video lecture, I am going to discuss the concept of hybridization. I have already introduced the definition of hybridization, the condition of hybridization, and the silent features of hybridization. So let us discuss in brief that actually what is hybridization. So hybridization is mixing of orbitals. Hybridization is your mixing of orbitals, whether they have, you can say, same energy or they must have slightly different energy. For example, if we consider a molecule like CH4, which is known as your methane. If we consider a molecule like CH4, that is methane. Suppose somebody asks you, what is the hybridization of methane? So actually this question is wrong. This sentence is not correct, that is the hybridization of methane. The correct question is, what is the hybridization of कार्बन इन मीथेन? तो कहने का मतलब ये हुआ कि किसी भी कंपाउंड में, किसी भी मॉलिक्यूल में हम किसी भी पर्टिकुलर एटम का हाइब्रिडाइजेशन पढ़ते हैं। तो इस मीथेन में हम कार्बन का हाइब्रिडाइजेशन पढ़ते हैं। सिमिलरली, इफ वी कंसीडर a molecule like PCl5, that is your phosphorus pentachloride. तो अगर आपको कोई पूछता है what is the hybridization of PCl5, तो कहने के लिए तो ये भले चल जाए, लेकिन ये क्वेश्चन जो है वो गलत है. The correct question is what is the hybridization of phosphorus in PCl5, and similarly if we consider a molecule like ammonia, then the correct wording is what is the hybridization of nitrogen in ammonia. तो हाइब्रिडाइजेशन जो होता है वो एक पर्टिकुलर एटम का होता है in a molecule. Now what happens during hybridization, which is very important? During your hybridization, different orbitals which are slightly differ in their energy, will intermix together. वो आपको क्या करेंगे? इंटरमिक्स करेंगे. फॉर एग्जाम्पल, इफ यू कंसीडर, थोड़ी देर के लिए मान लीजिए एग्जाम्पल आप लें, कार्बन इन मीथेन. तो यू नो कार्बन एटॉमिक नंबर इज 6. इट इज योर 1s2 2s2 2p2. तो ये मान लीजिए इनका इलेक्ट्रॉनिक कॉन्फ़िगरेशन है. नाउ particularly in hybridization, the different orbitals, it is also very important, during hybridization different orbitals of an atom different orbitals of an atom of a same energy level, of a same energy level. same energy level कहने का मतलब हो गया n value should be same. n means principal quantum number. यहां n कहने का मतलब क्या है हमारा? n कहने का मतलब है यहां प्रिंसिपल क्वांटम नंबर. n कहने का मतलब हो गया यहां आपको ऑर्बिट नंबर. इट मींस देयर विल बी ओवरलैप बिटवीन 2s and 2p. There will be overlap between 2s and 2p. ऐसा नहीं होगा. During hybridization, 1s will mix with 2s or 1s will mix with 2p. तो hybridization का मेन पॉइंट ये हुआ कि the different orbitals having slightly different in energy. Naturally है कि the energy of 2s and 2p will differ. Now again in 2p you know, again in 2p we have 2px, we have 2py and we have 2pz. तो 2px, 2py और 2pz इन तीनों की एनर्जी सेम है, but their energy is different from your 2s. So only orbitals which differ slightly in their energy, they will intermix together. ठीक है? And that must belong to the same principal quantum number or same orbit. इसका मतलब ये हुआ कि 3s, अगर मान लीजिए हम n is equal to 3 ले लें, फॉर एग्जाम्पल PCl5 का केस जब आप करोगे, फॉर एग्जाम्पल जब आप PCl5 की बात करेंगे, सो व्हाट हैपेंस इन फॉस्फोरस इज 15 configuration. You write 1s2 2s2 2p6 3s2 3p3. So what happens? 3s will mix with your 3p and it may mix with your 3d. It may overlap with your 3d. So one important criteria, one important happening during hybridization is, मतलब hybridization में और क्या हो सकता है? तो hybridization में आप ध्यान दोगे completely filled, half filled, completely filled, half filled, both type of orbital, completely filled, half filled, as well as you can see even vacant orbital also. So both can take part in overlapping. ठीक है, आप अभी कहोगे कि सर यहां तो 3D ऑर्बिटल नहीं, there is no 3D orbital, so how you can say this 3D will take part? हम देखेंगे कि 3D कैसे यूटिलाइज होगा. So that's why we can say even completely filled, half filled, or even vacant orbital, or you can say even empty orbitals may also take part in your hybridization if there is need. अगर जरूरत पड़ी तो, नहीं जरूरत पड़ेगी नहीं देगा. So in this case 3s will mix with 3p and 3d also. The one more important point is that is also very important. Only the orbitals present in the outermost cell, will intermix will intermix, or you can say overlap during your hybridization. Let us suppose हमने कार्बन इन मीथेन ही कहा, सपोज कार्बन इन मीथेन, सपोज कार्बन इन मीथेन. So you know carbon is atomic number 6, it is your 1s2 2s2 2p4. Now if somebody asks you what is the valence cell, valence cell means which cell is your outermost cell, you can say it is your second cell. Second cell means n is equal to 2. तो n is equal to 2 में आपका 2s ऑर्बिटल है और आपका 2p ऑर्बिटल है, इसीलिए यही केवल हाइब्रिडाइजेशन में टेक पार्ट करेगा. नाउ the another main point of hybridization is suppose we have one s orbital. Suppose we have one s orbital and 3p orbital. They are your px, they are your py and they are your pz. मान लीजिए कि ये 2s है तो ये 2px है, ये 2py है और ये 2pz है. So on the whole, if you count totally, you can say they are 4 atomic orbitals. यदि आप इसको काउंट करोगे तो आप कहोगे कि ये 4 atomic orbitals हैं. One is your 2s, another is your 2px, 2py and 2pz. They all are of n is equal to 2. ये सभी के सभी आपको सेकेंड ऑर्बिट में बिलोंग करेंगे. ठीक है. सो देयर आर 4 atomic orbital. If they do not mix, means before mixing or before overlapping, before mixing, they are referred as pure atomic orbital. They are referred as your pure atomic orbital. जब ये आपस में मिक्स नहीं किया, जब ये आपस में ओवरलैप नहीं किया, तो इनको हम लोग कहेंगे प्योर एटॉमिक ऑर्बिटल. बट व्हेन दे मिक्स टुगेदर, when they overlap together, when they mix together, when they overlap together, and after overlapping, the orbitals formed are known as hybrid orbitals. So it is also a silent feature. After mixing or after overlapping, the orbitals formed are known as hybrid orbitals. मिक्सिंग से पहले इनको बोलते थे हम लोग प्योर एटॉमिक ऑर्बिटल, बट जब ये आपस में मिक्स हो जाएंगे, ओवरलैप कर जाएंगे ड्यूरिंग द प्रोसेस ऑफ हाइब्रिडाइजेशन, और तब जो वो ऑर्बिटल्स फॉर्म करेंगे, दैट फॉर्म ऑर्बिटल्स आर नोन एज योर हाइब्रिड ऑर्बिटल्स. नाउ वन मोर इंपॉर्टेंट पॉइंट इज, यू कैन से not only point, that is the silent feature is, the silent feature is the number of hybrid orbitals formed is equal to the number of atomic orbitals takes part in overlapping. For example, consider in this case. So in this case what happens? we have 4 pure atomic orbitals which are taking part in hybridization. So therefore we can write the number of hybrid orbitals formed. Hybrid orbitals formed, it is also equal to your 4. Now let us suppose if there is another example. Suppose we have example that we have one s orbital and simply one p orbital. Say one s orbital, that is your 3s, and one p orbital, only one p, either of the p, because you know this px, this py and this pz, they are called your degenerate orbital. They are called your degenerate orbital. कहता है सर ये degenerate का मीनिंग क्या होता है? Degenerate का मीनिंग होता है कि इनकी जो एनर्जी है वो सेम है. जितनी एनर्जी px की है उतनी ही py की और उतनी ही pz की. सपोज px की एनर्जी 100 किलो जूल है, तो py की भी एनर्जी 100 किलो जूल और pz की भी एनर्जी 100 किलो जूल. सो फॉर एग्जाम्पल सपोज ये 3s है, तो यहां भी हमको 3p लेना होगा. वी कैन नॉट से यहां 3s ले लिया एंड यहां पे हम 3p लेंगे. नो, यहां 3s सॉरी यहां 3s लिया, देन वी हैव टू कंसीडर 3p. यहां अगर 3s है देन वी हैव टू कंसीडर 3p only. So what happens? This is 3s, this is 3p. So one of 3s and one of 3s में तो 1 ही होगा, s have only one orbital. मगर p में 3 होते हैं, so out of that 3, उस 3 में से आप कह सकते हो कि एक ऑर्बिटल, चाहे वो 3px हो, चाहे वो 3py हो, चाहे वो 3pz हो, कोई एक आपको यूटिलाइज हो रहा है इन हाइब्रिडाइजेशन. इट मीन्स the number of hybrid orbitals formed, it must be equal to your simply 2. It must be your simply 2. Now the another question, or you can say the another silent feature is if you consider, that is your for example, if I say in this case it will form 4 hybrid orbital, not sp, it will form your 4 hybrid orbitals. 4 hybrid orbitals. Now what will be the name of these 4 hybrid orbitals? The pure atomic orbitals are 2s, 2px, 2py and 2pz. So each of the hybrid orbitals, they are referred as your sp3, 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 sp3. आप कहोगे सर इसको sp3 क्यों कहेंगे? Why it is called sp3? Because in number 1s orbital and in number 3p orbital, px, py and pz. So it is sp3. But if we have 1s orbital, say it is 3s, and 1p orbital, say it is 3p, if they overlap, then they will form 2 hybrid orbital. One is s, another is p. So its name is your sp and its name is your sp. ठीक इसी तरह आप कहते कि एक ऐसा है, सपोज एक ऐसा है 3s और 2p. 2p means either it will be 3px or it will be 3py or it will be 3pz. उस 3p में से out of that 3p, px, py, pz, only 2 different p, either it is px or py, then they will form your 3 hybrid orbital. They will form 3 hybrid orbital. Now what will be the name of these hybrid orbitals? Each of them is your sp2. एक s है और दो p है, sp2 and sp3. Now when hybridization occur, the different atomic orbitals like 2s 2px 2py 2pz 3s 3p, yeah, 3s 3px 3py, they slightly differ in their energy. उनका एनर्जी थोड़ा डिफर करेगा, but when they form hybrid orbitals, then their energy will equalize. What does it mean? It means in this case all the four sp3 hybrid orbitals are of equal energy. इक्वल बोलिए या बेहतर होता है यहां आप बोलते हो इक्विवेलेंट, आर ऑफ इक्विवेलेंट एनर्जी. तो यहां जो मान लीजिए चारों आपको बना, ऑल द 4 sp3 दे हैव इक्विवेलेंट एनर्जी. Suppose pure 2s atomic orbital, it has energy of 100 kilojoule. Suppose, and this 2px, suppose it is your 120 kilojoule. Again, it has 120. It has 120. If you sum up all the energy, it is 100 plus 120 into 3. तो ये हो गया कितना? 360 plus 110. That is 460. 4 not 60, it is your 470 kilojoule. So 470 kilojoule is sum of energy of all the 4 pure atomic orbital. ये कब? Hybridization से पहले. But after hybridization we have to equally distribute this 470 kilojoule in 4 sp3. So if somebody asks you, अब अगर आपको पूछे, question हो गया आपको, what is the energy of a sp3 hybrid orbital? इस केस में, suppose this is the energy, then what will be the energy of your sp3 hybrid orbital? Can you tell me? It will be your, you can say it will be your 470 divided by 4. Why we divided by 4? Because we have 4 different sp3 equal energy, and you can say it is your 100 and near about 115, 116, 117.5. So it is your 117.5 kilojoule. So 117.5 kilojoule is the energy of your each and every sp3 hybrid orbitals. Similarly, let us suppose in this case, when the hybridization is sp, pure 3s orbital, suppose pure 3s orbital have an energy equal to 110 kilojoule. And a pure 3p, suppose it has a energy equal to 150 kilojoule. Suppose, let us suppose. Now, if somebody asks you, they hybridize to give 2 sp hybrid orbital, then what will be the energy? आप क्या करोगे? इस 110 में 150 को add कर दोगे, it will be 260. Now there are 2 sp hybrid orbital. आपके पास 2 sp hybrid orbitals हैं, आप इनको 2 से डिवाइड कर दो. So the energy of your each sp hybrid orbital, you can say it is your 130 kilojoule per. And one more important point is, all these hybridized orbitals, they are of equal shape. उनके शेप भी सेम होंगे. एनर्जी सेम है तो उनका शेप भी सेम होगी. Pure atomic orbital, they are of different shape. You know, S is a spherical, P is dumbbell. S is a spherical, P is dumbbell, D is double dumbbell shape. अलग अलग शेप है, S का अलग शेप है, T का अलग शेप है और D का अलग शेप है, लेकिन जब वो हाइब्रिडाइज करके हाइब्रिड ऑर्बिटल्स फॉर्म करेंगे, देन each and every sp3 hybrid orbitals are of equivalency. Each and every sp hybrid orbitals are of equivalency. Similarly, each and every sp2 hybrid orbitals, they are also of equivalency. So I hope it is clear. Now, the remaining materials I will discuss in my next video lecture.